Experts considered Project Object 140 to be one of the most ambitious Soviet tank designs of the Cold War era. The government poured millions of rubles into building it, with estimates putting the total cost at around 16 million. Yet financial authorities later wrote off every cent without penalizing anyone involved. The tank plant's chief designer personally went to the top brass with the proposal to shut the whole thing down. Up until that point, defense plant directors almost never took it upon themselves to cancel their own long and expensive programs. The higher-ups reviewed the request right away and, without any pushback, made the call to close it down. The sheer number of technical problems and design flaws forced the developer himself to pull the plug. The story of this tank goes back to the early 1950s, when the industry was moving toward entirely new standards in armor design. After World War II, engineers came up with the T-54 medium tank, which became widely used and earned a solid reputation among military experts. They built it using real-world experience and tactical lessons picked up during the massive combat operations of the war. But by the early 1950s, military leadership took a hard look at the situation and realized how fast technology was advancing in other countries. Teams in the United States and Great Britain were actively developing new anti-tank systems, and experts predicted the T-54's armor would quickly become outdated against next-generation shells. The military needed a completely new tank, one that engineers would have to build from scratch based on fresh ideas, not just tweaking older designs. In the early 1950s, a team at the Ural Tank Plant in Nizhny Tagil kicked off preliminary studies for a new tank program. By 1953, the work had formally begun, and engineers gave it the official name Object 140. The project was handed to the plant's chief designer, Alexander Morozov, a man with decades of hands-on experience. Under his watch, the team had previously built the T-34. Morozov took over as chief designer of the project after the original lead, Mikhail Koshkin, died in 1940, and he ran the T-34 program through the rest of the war. The new assignment called for a tank that would beat everything else out there in firepower, mobility, and protection. The engineers in Department 520 dove right in. Their goal wasn't just to roll out another upgrade, they wanted to build something fundamentally new. The team experimented with different hull shapes, tested new materials, and explored unconventional layouts. They engineered every single component from scratch, refusing to fall back on older, tried-and-true designs. This approach pushed the boundaries of what the plant had done before and set out to define the next generation of their tanks. But all that ambition created the first major problems. Right from the layout phase of the hull and transmission, a bitter conflict broke out among the engineers. They argued over fundamental design choices, and these debates quickly turned into a real standoff. Plant management pushed for one approach. The military wanted something different, and the designers themselves split into several camps. Morozov insisted on his own vision, but the leadership at the Ural plant wouldn't budge. Tensions inside the design bureau grew by the day, and in 1952, things reached a boiling point. Alexander Morozov made a decision that changed the entire project. He gathered a group of like-minded colleagues and left Nizhny Tagil, heading to the design bureau at Kharkiv plant number 75. The engineers who went with him knew the project inside and out. On top of that, they took all the blueprints and technical ideas the team had put together while working on Object 140. Once in Kharkiv, this group immediately got to work on their own vehicle, later called Object 430. So now, two plants were essentially working on the same thing. They were using the exact same design ideas, but at the same time going head-to-head for the government contract. Back at the Ural plant, Leonid Kartsev stepped in as the new chief designer. In March 1953, when they officially gave him the job, he was just 30 years old. Leonid Kartsev took over a project that Morozov had walked away from, and he was determined to finish it. He knew exactly what he was up against. He was competing with the man who had run the T-34 program. The main armored directorate was openly backing the Kharkiv team. The Tagil plant only got into the project in the first place thanks to Yuri Maksarev, the Minister of Transport Machine Building, who stepped in on their behalf. But none of that stopped Kartsev. He had his engineering team and the manufacturing muscle behind him. He was going to prove that Nizhny Tagil could hold its own. Deputy Chief Designer Valery Venediktov took direct charge of Object 140, with Ivan Bushnev coming on as lead engineer. The team hit the ground running, trying to make up for lost time and give the Kharkiv guys a real run for their money. The goal was to build a machine under 36 tons that would outdo the T-54 across the board. The engineers got creative to shave off as much weight as they could. One of their tricks was using bent side hull plates with a variable width profile. This let them widen the turret ring without making the hull any bigger. They also got rid of some transitional armor pieces that were just adding dead weight. The catch was that only one factory in the whole country, the Ural plant, could actually make the blanks for these side plates. That right away raised red flags about scaling up production down the road. But the designers kept at it, because every pound they saved opened up new possibilities. For example, an engineer named Alexander Barakin came up with the idea of stamping the road wheels out of aluminum alloy. This had never been done before in Soviet tank building, and it made a huge difference in weight. 6 road wheels on each side instead of the usual 5 spread the load more evenly across the tracks, and because they were bigger, the tank could go faster. The designers also cast the engine deck cover out of aluminum to save even more. But the boldest move was how they mounted the engine. They went totally against convention and laid it on its side. They put the 580 horsepower TD-12 diesel in the back, turned sideways across the hull, tilted at a 7-degree angle, and shifted toward the left. This let them drop the roofline of the engine bay, making the whole tank sit lower and a lot harder to spot on the battlefield. That low profile was a real tactical advantage. The engine was designed by Yevgeny Artemyev and his team, and they set up production at the Barnaul motor plant. This naturally aspirated, water-cooled, 12-cylinder diesel weighed exactly 1,000 kilograms and made peak power at 2,100 revolutions per minute. But because it was sitting in such a weird position, the team had to completely redo the crankcase, the crankshaft, and the cooling and lubrication systems. They were basically building a whole new engine out of an existing one, and that ate up a ton of time. Meanwhile, a group of engineers led by Ivan Nabutovsky, Vladimir Semenenko, and Viktor Drabotenko came up with special rack-style fuel tanks. They worked the fuel cells right into the ammo storage. That one move boosted ammo capacity by 47% and fuel supply by 33% compared to the T-54. Later on, they used this same setup on the mass-produced T-55, where it worked great. The running gear on Object 140 also had some big upgrades. A longer suspension arm with a cantilever mount gave the road wheels 242 millimeters of travel, way more than the 140 on the T-54. Hydraulic shock absorbers on the front and rear smoothed things out over rough ground. For the first time, they added return rollers, 3 per side, which made the tracks run more efficiently and let the tank keep up higher average speeds. The weapons package matched the tank's unique design. At first, they planned to use the 100mm D-10T cannon. But by the mid-1950s, the Design Bureau pushed for a different option, the D-54 TS, which came with a 2-plane stabilizer. That meant the crew could fire accurately while moving, a big deal in mobile combat. They also mounted a hull machine gun and a coaxial 7.62mm machine gun, plus a heavy anti-aircraft gun on top. In February 1956, the team showed off a full-size wooden mock-up to the review commission. The panel looked it over, checked the hatches, and sized up the layout of the fighting compartment. The Tagil plant had actually finished the technical design back in late 1955, ahead of the Kharkiv team. but the commission sent the mock-up back for changes, which cost them valuable time. By November 1956, engineers delivered all the working drawings for Object 140 to the factory floor. Now it was time to actually build the thing out of metal. The plant ran 3 shifts because speed mattered. The Kharkiv team was right on their heels. Every part needed extra care since nobody at the plant had ever built anything like this before. The foundry guys had to figure out how to cast aluminum road wheels. The welders had to learn how to handle bent armor plates with complex curves. And the assemblers had to find ways to fit everything together inside a very tight engine bay. By May 1957, the first prototype was ready. When they rolled it out of the shop, everyone could see this was something different. The tank was unusually low to the ground. Its flat, rounded turret blended right into the hull, and the smooth lines were nothing like the boxy shapes of the tanks they were building at the time. The cast turret had a narrow slot for the main gun and gave solid protection without adding much weight. The front of the turret was 240 millimeters thick, the sides were 220, and the whole thing still came in at exactly 36 tons. Testing started right away. The driver climbed in on the left side, fired up the engine, and drove out onto the test course. The first few kilometers went smoothly. The tank handled obstacles well, the suspension ate up the bumps, and the gun stabilizer held the barrel steady even over rough ground. Things were looking good, and the team felt like all the hard work was about to pay off. But then problems showed up. After 86 kilometers, the engine started acting up, and then the transmission gave out completely. They stopped everything to figure out what went wrong. When the mechanics cracked open the engine bay, they found a whole list of issues. That unconventional engine layout was messing with the lubrication and cooling. Oil was collecting at the bottom of the crankcase and not getting where it needed to go. They pulled the cooling system out and ran thermal tests, then built a new ejector based on what they found. At the same time, they discovered that the rubber on the aluminum road wheels was wearing out way too fast. Cutting all that weight had hurt reliability, so the team scrambled to find tougher rubber compounds. These setbacks were bad news for the Tagil Bureau, especially since the Kharkiv plant was busy putting together its own competing prototype. Kartsev pushed his engineers to fix everything as fast as possible. By December 1957, they had a second prototype ready. This one had a reworked cooling system and beefed up road wheels. They fitted the main gun with an improved 2-plane stabilizer called the Vuga, which was way more accurate on the move. The tank also got a telescopic rangefinder sight, night vision gear including the Uzor, Ugol, and Luna 2, and a modern R-113 radio. In terms of electronics, Object 140 was more advanced than any Soviet production tank at the time. Both prototypes then shipped out to the Kubinka Proving Ground near Moscow. That was where the Armored Vehicle Research Institute put all the promising new designs through their paces. The Kharkiv Object 430 was already there, so now the experts could test them side by side. Whoever won these trials would get the contract for the next main battle tank. The commission ran every test in the book, pushing both machines to their limits. Testers measured everything, from fuel to the temperature of the air. The crews shot at targets from different distances, both parked and on the move. The testers measured everything, from fuel burn to how tight the shot groups were. And as the days went on, it became obvious that Object 140 had a serious problem. The tank could drive and shoot just fine, but when it came to fixing it, that was a different story. The review board watched mechanics struggle just to get at the engine compartment. Because the engine was laid on its side and crammed up against the hull wall, basic maintenance was nearly impossible. To swap out certain parts, they had to jack the tank up on special stands and go in through hatches on the bottom. There was no way any crew could do this kind of work out in the field. The committee zeroed in on how the steering linkages connected. Even the most experienced mechanics could only do the job using a mirror, because you literally could not see the parts any other way. To change the fuel injectors on the lower part of the engine, they had to go in through bottom hatches, lying flat on their backs in a cramped space. The underside of the hull had all kinds of access panels, each one designed for a very specific part. Chief designer Kartsev went over the comparison results carefully. Object 430, built by a rival team that had studied the first tank's mistakes, came out way ahead when it came to everyday maintenance. The other team had clearly learned from what went wrong with Object 140, and they built a much more practical machine. Kartsev could see that his tank wasn't losing on firepower or performance. It was losing on repairability, and that was what the military cared about most. He had a choice to make. He could keep throwing time and money at fixing deep-rooted design problems. Everyone on the team agreed that, at least on paper, they could probably get the machine to work reliably. But that brought up an obvious question. How much more money would they have to burn on a machine that had fundamental issues baked in from the start? And would the military even wait around for the fixes, when another bureau already had something ready to go into production? Kartsev kept going back to the test reports, looking for some way forward. Only one factory could make the bent side plates, which made scaling up production a nightmare. The aluminum fuel tanks were warping because they picked the wrong alloy. The hull welds didn't have proper interlocking joints, which meant the tank wouldn't hold up well under fire. And the list of problems grew longer every day. Kartsev was under enormous pressure. He spent sleepless nights going back and forth. He thought about the workers who had poured themselves into building the prototypes, the engineers who had spent years on the drawings, and his own reputation, which was definitely going to take a hit. But more than anything, he kept thinking about the crews who would have to take these machines into combat. Could a tanker actually fix this engine out in the field when things went sideways? Would this tank get back in the fight after a breakdown, or would it just sit there like a target? In the end, a clear-eyed look at the facts won out over personal pride. After going back and forth, Kartsev made his call. He wrote an official letter to the country's top leadership. It wasn't easy to write. He asked them to pull his bureau off Project 140 and shut down a program that had already eaten up years of work and a fortune in funding. Nobody did this. In the defense world back then, designers fought for their projects to the last breath, doing whatever it took to keep the money and the work flowing. To the people around him, walking away from his own project looked like admitting defeat. Kartsev knew some of his colleagues would see it as selling out the plant. But he believed he was making the right call, putting the military's needs ahead of his own pride. Once the letter went out, all he could do was wait. He expected the worst. In earlier times, something like this could have ended a career, or worse. The political atmosphere had lightened up a bit by then, but blowing through 16 million rubles of government money still meant somebody had to answer for it. The response came fast, and it caught everyone off guard. They approved his request. In his memoirs, Kartsev wrote that the officials actually took it well and even seemed to respect the move. A commission formally shut down the project in June 1958. The financial authorities wrote off the 16 million rubles without docking anyone. Kartsev didn't face any consequences at all, not even a formal reprimand. In hindsight, it makes sense. The people at the top had been leaning toward the Kharkiv design for a while. They had backed Morozov's project from day one and really only let Kartsev's team in to make it look like there was an open competition. His letter actually bailed them out. They didn't have to be the ones to kill a failing project or explain where the money went. Kartsev basically took the fall so they didn't have to. Even so, the relief of having it over didn't erase the guilt. Kartsev looked back on this period for years with real regret, feeling personally responsible for the millions that got written off. That money could have gone to hospitals, schools, or the broader economy, and instead it disappeared into a dead end. But over time, it became clear that Kartsev made the smart move. His honesty saved a lot more money down the line, money that would have been wasted trying to fix a design that was never going to work. After the project ended, 2 experimental prototypes of Object 140 sat at the Kubinka proving ground. The story could have ended there. But even though the program was dead, the engineers saw real promise in some of the ideas and held on to them for future work. The experience they gained fed directly into later projects. They went back over the test data, studied the failures closely, and folded everything they learned into new designs. Take the spent shell ejection system. The engineers designed it for Object 140, but never actually installed it on the prototypes. Still, the concept itself impressed the commission, and they recommended putting it into future tanks. The idea was to automatically kick spent brass out of the crew compartment. That would cut down on toxic fumes and take a lot of strain off the loader. A few years later, designers took this concept and built a working version for the Object 165. When that tank went into service, it got the name T-54, and it became the first production tank with a smoothbore gun. The six-wheel suspension with big aluminum road wheels also had a major influence on later Soviet tank development. The engineering ideas tested back in the 1950s eventually became standard for the next generation of Soviet combat vehicles. By the late 1960s, when designers started work on a completely new main battle tank, they built it right on top of this foundation. The T-72, which ended up being produced in huge numbers around the world, got its suspension layout straight from this earlier work. That basic design is still in use more than 50 years later. The rack-style fuel tanks that Nabotovsky, Semenenko, and Drabotenko came up with went into production vehicles almost right away after the project shut down. The T-55 already had this system, which made smart use of space inside the hull. Putting fuel and ammo storage together became a go-to move in Soviet and later Russian tank building, and updated versions of the idea are still showing up in modern vehicles. The engineers also kept working with aluminum alloys to cut weight. They learned from the fuel tank mistakes and picked better alloys going forward. The aluminum road wheels that first showed up on Object 140 are now on every tank in the T-72 and T-90 families. Armies around the world use these vehicles in all kinds of conflicts, and the running gear still holds up, thanks to ideas that go back 70 years. After the whole experience, Leonid Kartsev took away the biggest lesson of his career. He realized that chasing breakthrough technology shouldn't come at the cost of making a vehicle that crews can actually keep running. He adopted a philosophy that a tank is a tool, period, and the people inside it need to be able to fix it themselves in the field with whatever they have on hand. Kartsev made this principle the foundation of all his future designs, and the Nizhny Tagil plant built a strong track record under his leadership. The Ural plant went on to produce several well-known models. The T-62 had a pioneering smoothbore gun and automatic shell ejection. The T-72 became the most mass-produced tank of the second half of the 20th century. Armed forces from many countries deployed Kartsev's machines in dozens of conflicts across different continents. They saw action during the Yom Kippur War and Operation Desert Storm, though in both cases they took serious losses against Western armor and anti-tank systems. Every one of these later machines carried ideas that first showed up on Object 140. The Kharkiv competitor, the whole reason the Tagil project got shut down, never made it to mass production in its original form either. Designers kept reworking Object 430 over and over until it finally turned into the T-64. That vehicle kicked off its own branch of tank development, running parallel to what the Nizhny Tagil engineers were doing. So two plants that started on one shared project ended up creating two completely separate lines of combat vehicles, and both of those design philosophies are still alive today. Down the road, developers took parts from one of the Object 140 prototypes and used them to build their next tank, Object 167. They stripped the old machine down completely and worked every usable piece into the new project. Nothing went to waste. Today, the only surviving Object 140 sits in the Armored Vehicle Museum in Nizhny Tagil. It has a low profile and a rounded turret that makes it stand out from everything else on display. This prototype had design features that were way ahead of their time, and it laid the groundwork for later Soviet and Russian tank models still in use today. In 2003, a group of experts, researchers, and retired engineers got together for a special conference, marking 50 years since Object 140's development began. Former Design Bureau staffers shared their memories of building the vehicle and the heated debates that came with it. Everyone there agreed the engineers absolutely could have made this tank work, but they also agreed that Kartsev's decision to walk away was the right call. It is a reminder that knowing when to stop and move on can sometimes be the smartest engineering decision of all.